Thank you, Climate Response Committee. Thank you, Library, and in particular, thank you, Catherine, who is running all around behind us here, making it all work. Couldn't do this without you. Thank you. So I want to start by giving you a little background on how and why I'm doing what I'm doing. That is speaking up here. In 1980, I guess you'd say my climate journey began. 1980, the climate change amendments were passed, and they gave some teeth to the Climate Change Act, which happened 10 years earlier, but didn't have any teeth to it. So I was running a printing company just outside of Lancaster, Pennsylvania, and we had a visit from the EPA, Environmental Protection Agency, and they climbed up on our roof and measured stack emissions coming out of the stacks on the roof. And a few days later, they came back to us with a huge fine and all sorts of penalties if we didn't shut down those emissions very quickly. So the fine was for VOC and NOx emissions. I had no idea what VOC and NOx emissions were or are. So I had to get up to speed kind of quickly. So the Graphic Arts Association started an environmental group. And at first our attitude was, why is the government imposing these very onerous regulations on us? And as I went through the list of chemicals that they were banning, the printing industry couldn't survive without those chemicals. At least we didn't think so. So it reminds me a little bit of what's happening with the lobstering industry right now in terms of the government saying, you can't do this. So a group of us started something called the Environmental Conservation Board because we realized that maybe the government regulations weren't that onerous. Maybe we were really bad actors. And in fact, the printing industry was polluting a lot. You can imagine all the dangerous chemicals used in film processing, plate processing, all the solvents used to wash up. We were using a lot of toxic chemicals. We were polluting a lot. So the Environmental Conservation Board was started to find solutions. And fortunately, frankly, it was during the Clinton administration, he set up something like the Common Sense Initiative, and he picked the printing industry to be a partner with the federal government. So we had a lot of resources to basically change the industry. And over the next almost 10 years, we changed printing into a very environmentally friendly industry. We got rid of isopropyl alcohol, we got rid of our VOCs, we volatile organic compounds. And if you don't know a VOC, it's volatile organic compounds or compounds which, when they evaporate, which they all do very quickly, when they get hit by sunlight, they turn to ozone. Ozone's a great thing in the upper atmosphere. In the lower atmosphere, ozone is smog, so it's very unhealthy. Anyway, so I, for about 10 years, worked on pollutants and toxins in the industry. We had all kinds of great resources. We also involved the printing industry, getting rid of elemental chlorine and paper making and things like that. And after about 10 years, I felt the ECB had done what it was set out to do, And so we shut it down and basically let the printing industry trade associations teach. At the time, there were 68,000 printing establishments in North America. We let them to sort of teach. We had done the technical side, which is what we were founded. So I thought I was finished with environmental affairs. And this is sort of somewhere around 1995. And then about 10 years later, I had a phone call from one of the chemists who had worked for ECB, and he said, Karl, you paying attention to carbon dioxide? Now what? You gotta be kidding me. And he said, because this is the big one. All the work you did for toxins and pollutants, whatever, it's the greenhouse gases, carbon dioxide, that's what's gonna get us. Well, I was very skeptical because carbon dioxide, we all know, that's what we breathe out. That's what the plants breathe in. It's been a natural cycle for as long as there's been life on Earth. What could be wrong with carbon dioxide? So about that time, a guy named Bill McKibben started an organization called 350.org. If you've heard of it, haven't heard of it, it's an organization. Oh, didn't go darn. 350.org was founded because a group of scientists believed that anything above 330 parts per million of carbon dioxide would cause massive extinctions, would cause huge change in the environment. So when he started it, we were at 330, and the hope was we could stop before we got to 350. We're now at 420 plus. So I started giving these talks 15 years ago. And frankly, when I started giving the talks, people thought global warming was a hoax. It wasn't going to happen. None of what we're seeing today that's beginning to happen, nobody believed it. In fact, I used to not use the term global warming because every time there was a cold day, people said, see, this is proof. There's no such thing as global warming. Trust me, there were a lot of people in that school, still are. So what I wanted to talk about today is why are we responding so slowly? And I'll move into sort of the technical aspect of it. But the top thing is too many people don't grasp the urgency of what's happening. People think, well, if it gets worse, okay, maybe I'll have to get air conditioning someday. Or, thoughts like that. People don't realize what a few degrees will do in terms of changing species, changing all kinds of things. We are doing a lot as far as energy efficiency. We've gone to CFL bulbs, there's a whole lot being done. The problem is the demand for energy is still growing at a faster rate. So we are still increasing every year more and more, and it's building up. Human nature is, of course, doubting what you don't see. Human nature is fighting against us, unfortunately. Fear of change. A lot of people don't believe it's going to change, and they think they're just afraid of what might happen, and fear breeds lack of action. So, lack of understanding, it's been my contention for a long time that if people don't understand, they won't get engaged. And if we go to the next slide, I've had the pleasure of talking to a number of legislators, state and federal, and some people who are on energy and environmental committees. And my questions are the ones who were willing to meet with me, because they were the ones who would say, yes, I believe that climate change is a real problem, and I'm going to do everything I can, in the House or the Senate to work on it. And then I asked the next question, do you understand it? And the response I always get is, well, not really. But I don't have to understand it all the way. I'm not a technical person. Well, if they don't understand it, they're not engaged in it sufficiently. They're not committed to it enough. And that's what I see happening. That I see a lot of, in Washington, at the state government level, I see a lot of talk, but I don't see action and commitment. Other priorities come up, and economic issues always seem to come ahead of the environment. So social pressure, peer influence, we all tend to pay attention to what our neighbors are doing. If everybody in the neighborhood is putting solar on, you're more likely to put solar on. Of course, that's another issue right now. And social pressure, oh, have you done this? Have you done that? Well, no, I haven't done it yet. If you're building all the pressure, go back and forth. Reluctance to change. Nobody likes change except the baby with a wet diaper. We all know that. Convenience preference and luxury preference. If you look at a good example of luxury preference is what I call fast fashions. Why do you keep buying clothes you don't need? Why do you keep buying things you don't need? Why do you do so many things for comfort and luxury that you really don't need? And a lot of it has to do with advertising, promotion. What Madison Avenue is all about is getting you to buy more stuff. And temporal myopia. This is a funny word, but it's the inability that everybody has to sufficiently consider long-term consequences when we have choices. So evidence the federal government, not funding Social Security, not funding Medicare, and not reacting to climate change. So always keep in mind political, religious, and social beliefs outweigh facts. So a great example I'd like to give, I spoke several years ago with a church group, And this one fellow had a bunch of questions, and turns out he was actually a rocket scientist. He worked for General Electric, and he had all kinds of doctorates, and he designed rocket ships. And he said, I think your talk is pretty good, but I don't believe global warming is actually going to happen. So I said, let's get together. And I bought this fellow breakfast, and he said, well, I'm not sure about this part. And I'd go home and I'd send him a whole bunch of articles and some graphs. And he'd say, okay, I got it. I still don't believe in climate change. Breakfast again. Same thing again. Third time we went to breakfast, I said, now what? And he said, well, technically, I agree with everything you said. But I don't believe in climate change because God wouldn't do this to us. And this isn't a joke. There are a lot of people who that's what they're thinking. So bear in mind, we have a lot to fight against. Next slide. So you all know that the radio, the TV, when a storm comes through, any kind of big storm, they blame it on global warming. And anybody who's remembering the last time we had a big storm or the storms we've had for our entire lives says, well, that's who we've always had hurricanes. Why is this hurricane based on global warming when the others haven't been? Well, the problem with the media saying that is they are killing the credibility. They're causing people to be skeptical. We've always had hurricanes. We're always going to have hurricanes. So the media using it as an excuse, whatever. So projections and interpreting data. The next few slides I'm going to get into make it clear what is actual data, what is fact, and what is a projection. And people can doubt the projections with good intentions. But my point is, let's look at the facts. Just pay attention to the facts. Don't pay attention to what people are saying might happen. The trade-offs. Actually, Cy gave me a good example the other day I'm going to use. When people cut down huge amounts of woodland, which is absorbing lots of carbon dioxide, cut down all the trees and fill it with solar panels. Wait a minute, there's something wrong here. Well, that kind of thing is happening all over the place. There are all sorts of things that are being done that are cutting back on the natural sequester of carbon dioxide for a modern approach to either sequestering or creating more energy. There are always going to be those trade-offs, both monetary and perception of what's green. Bear in mind, energy is the key to this. We have to have energy. We need more energy. Traditionally, energy comes from fossil fuels. Back when I was first starting this, I always thought, growing up in the manufacturing world, that the higher your electric bill, probably the better your billing was. Productivity went hand in hand with using more energy. So how can we say we have to stop using so much energy? So elected officials with less understanding, insufficient committed leadership. And a good point of this is nuclear energy. If anybody in government says they are in favor of nuclear energy, they probably won't win re-election. It's a pretty good chance of that. They're all afraid to talk about nuclear. And let me just say about nuclear, if you think about nuclear for a minute, we've only had three nuclear disasters, right? We had 3 Mile Island, which actually nobody got hurt. The mechanisms worked. They shut it down. They prevented any radiation from escaping. So that was TMI. We had Fukushima, which was an absolute disaster I won't get into it. And we had Chernobyl, okay? All highly publicized, all terrible events, but we've only had 3. And on the scale of all the things that have happened with gas, oil, coal, 3 is pretty good. Also consider that all the nuclear plants that are now operating in North America were designed in the 1950s. So the current plants are working on old technology. They're working on relatively old safety processes. I'm not saying they're a threat, But what I'm saying is the new technology has come a long way. So nuclear today is safe, it's efficient, it's much cleaner. You may not realize that France gets all their electricity from nuclear. There happens to be, there's a big push right now on what they call small modular reactors. You get a huge amount of power out of a small reactor with very little radioactive content. There's actually a company that I'm following closely in Camden, New Jersey, that recently signed some contracts, several in foreign countries. They're close to a final contract in the US to build a small nuclear reactor. They were saying a reactor that's about the size of a tractor trailer could provide all the electricity for a city the size of Portland. That gives you an idea of the scale. They're making them air cooled as well as water cooled. So there's some great technology coming in nuclear. And most of the world is paying attention to this. African countries, a bunch of them have signed up for these small modular reactors. And we need to get on the stick, but talk to your senator and congressman and they say nuclear is a bad word. You can't talk about that. Conspiracy theories, you know, I'm not going to get into that, but we hear some real Looney Tunes, not just on energy, but on all kinds of issues. But that does certainly stand in the way for some people. Slide. So the global issues, you've probably heard these stats before. The wealthiest people in the world emit about 10% of the greenhouse gases. I'm sorry, the wealthiest 10% emit 45% of global gases. The poorest 50% emit 13%. So huge imbalance. The poorest nations want the prosperity we have. Who's going to tell the people who live in India or Sri Lanka or similar countries that they can't have what we have? They want our electric appliances. They want, I mean, even in China, you're not allowed to buy a clothes dryer in most of China. Of course, they want clothes dryers. They want air conditioning. They want all kinds of blaming other countries. A lot of people say, well, China is the culprit here. China is, but China's population is many multiples of ours. On a per capita basis, we are the world's polluter. We are the world's emitter. No question. But you can't really blame other countries. Population growth globally is a problem. You know, we have all kinds of zero population growth things going on in some areas, but as a world, population is going to continue to grow. And with it, energy demand is growing. So to get ahead of this, we've got to be doing more than just taking care of the current demand for energy. Migration is another big issue globally. As sea level rises, people are going to have to move. Paul Majewski made a statement at our meeting in August that he thought the population of Maine is going to double in the next 10 years. Hard to fathom, but if you look globally at it, where are those people going to go? There just isn't. There are many nations that are going to be swamped, island nations that are going to be swamped. They've got to go somewhere. If you look at the United States, if you look at a map of elevation, everything east and south of Raleigh, there's nothing higher than 50 feet above sea level. So consider the whole southeastern US. Where are they going to go? I'm not overstating it if I say within the lifetime of probably some of the people in this room, Florida is going to be a huge evacuation zone. Where are they going to go? Next slide. So greenhouse gases. The greenhouse gas is a gas that traps heat from infrared solar radiation. If you doubt it, get yourself 2 bottles. Take two 2-liter soda bottles. This is something that a lot of high schools are doing these days, or even middle schools. You take 2 soda bottles, you fill them both halfway with tap water. You take one of them and you break up an Alka-Seltzer and you drop it in. The fizz in Alka-Seltzer is carbon dioxide. That's easy to prove. You put a cap on it, or ideally you take a little mercury thermometer and you wrap some tape around it so you have a tight fit in the cap. Tight fit in both caps. You got 2 thermometers, 2 identical bottles. This has got a half an Alka-Seltzer pill. This doesn't. And then you expose it to a heat source, ideally like a heat lamp. but some kind of identical source that has infrared warmth in it. And after about 5 minutes, you look at the thermometers, and the one with the Alka-Seltzer is measurably warmer. And it keeps on getting warmer. And then you turn the light off, go home, come back next day, the one with the Alka-Seltzer is warmer. It retains the heat. It gets hotter, faster, and it retains it. So you can prove it to yourself if you don't believe that top line. So the greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, ozone, and the fluorinated gases, CFCs. And so water vapor we don't worry about because it precipitates. Okay, water is heavy, so it rains, water vapor falls out of the air. It stays in the atmosphere for a very short time, but it does trap heat while it's there. The big one is carbon dioxide. Carbon dioxide is the one we're paying the most attention to. Methane is the fastest growing of these. Nitrous oxide, not a big deal. Ozone isn't usually looked at because we want more ozone in the upper atmosphere. We just don't want it at ground level. And the fluorinated gases are the chlorofluorocarbons, which the Montreal Protocol banned, but we still have it in our air conditioners, in our refrigerators. So if somebody wants to charge you a lot of money to put new refrigerant in your whatever cooler, freezer, air conditioning, it's because the gases that the machine came with are probably now banned, rightly so. So combustion or burning of fossil fuels emits greenhouse gases. So fossil fuels, basically a tiny bit of carbon chemistry is that carbon, organic chemistry is what all life is. The basis of all life is carbon. So when a living organism dies or ceases to live, something happens to that carbon. If living organisms have been millions of years on the earth, they get compressed with heat and pressure, and they turn into fossils. So liquid, gaseous, and solid state of fossils. Liquid state is oil, the solid state is coal, and the gaseous state is natural gas. So that's what happens to the fossils. They create one of those three types of what becomes a greenhouse gas when it's released and burned. So, natural gas is about 85% methane. It varies quite a bit according to what wells it's coming from, where it's coming from. Worth noting that the Marcellus Shale in Pennsylvania, Ohio, and West Virginia has about 15% ethane, which is the primary building block of most plastics. So that's why we're still at a very big rate mining natural gas. So even wood emits CO2 when burned, but not as intensely. That's why your wood fire is not as efficient as your coal fire, because it's not burning as much. It doesn't burn as hot. It's not emitting as much, but still it's emitting CO2. So methane comes from natural gas, fossil fuel processing, oil wells, abandoned, all these things that methane comes from. The big difference is methane was not in any large quantity on Earth until we started burning fossil fuels. And it's growing at a frighteningly fast rate. CO2, on the other hand, has always been in the atmosphere. It's part of our natural cycle. Jump to the next slide, please. So, for more than 400,000 years, and I'll back up and say, how do you know what happened 400,000 years ago? Well, not to hit Paul Maevsky again, but he is one of the world leaders in this research. And he has been part of these expeditions that have done core drilling in the Arctic, in Greenland, Mount Everest, and they go down far enough that they can actually, there's a little layer every year, they can get down 800,000 years in some cases, 400,000 years in the case of this chart, and they can read what average temperatures were, what CO2 levels were. They can actually pick that out, and this is verified by NOAA, by NASA, by Scripps, by you name it. Everybody agrees with this data. What you're seeing here is cycles. Some people say, well, global warming just goes in cycles. Well, look at the middle. They're your cycles. That's what's happened. That's why it's gotten warmer, colder. You know, the bottoms of these are ice ages at the bottom. Okay, so CO2 concentration and sea level are essentially running parallel to this. So when you had global temperatures down here, you know, ice age, you have whatever, very low sea level because it's all turned to ice. Next slide, please. So some people say, how can greenhouse gases make such a difference when all greenhouses combined are less than 0.46% of the atmosphere? And the atmosphere is mostly nitrogen, oxygen, argon, and then a whole bunch of that stuff. And then somewhere way down there, you come across the greenhouse gases. So it's a tiny bit of the atmosphere. But carbon dioxide produces 91% of greenhouse gas volume. Methane is 0.5% of greenhouse volume. Carbon dioxide accounts for 80% of global warming. Methane for 15% of global warming, but methane is 30 times more potent than carbon dioxide. Key to remember, CO2 stays in the atmosphere for an average of 7 days, and it rains. Methane stays in the atmosphere for about 9 years. Carbon dioxide stays in for, the average is actually more than 100 years. That's why if we stopped emitting today, there will be no reduction in CO2 for at least 100 years. Everybody got that one? Yeah. Key point. Methane concentration is currently 2.4 times higher than it's been in 800,000 years. So you might say, well, what's reacting so slowly? Well, we've never been here. You know, we've not witnessed what's happening. So how do you predict? All kinds of projections are made. Lots of people who are saying how fast sea level is going to rise, things like that. There is no data to prove any of that. There's data to prove what's happened so far. So carbon dioxide concentration due to natural emissions, it's never been above 350 and 330 until recently. And much 280 was the highest it's been prior to the start of the Industrial Revolution. If you go back to 1880, the records show that CO2 was never more than 280 parts per million. So it jumped from 280 to 330, and then in the last few years, it's taken off. Next slide. So this is probably one of the most revealing charts, a NOAA chart. The red is temperature, the blue is carbon dioxide. Okay, so it's the same chart that you saw before, except it extended out 800,000 years, so you can see what the cycles have been. Now put it in context, because you hear the UN, you hear the COP conferences talking about we cannot exceed an increase of more than 2 degrees centigrade. Well, the whole variation in 800,000 years, the variation in temperature has been less than 14 centigrade degrees, which is about 25 degrees Fahrenheit. That's been the coldest and the warmest the Earth has been as far back. So 800,000 years ago, CO2 concentration not exceed 330. Right now it's at 421. When I first used this chart, it was 2014 when NOAA came out with this chart, and we were at 400. So in 9 years, we've gone from 400 to 421. It's accelerating. So the last time carbon dioxide concentration was at its current level was 10 million years ago. And at that time, sea level was more than 100 feet above current level. So when people talk about sea level rise, if you look at it in the context of CO2, if you look at it in the context of greenhouse gases, we're not talking feet, we're talking meters, we're talking, you know, when I say more than 100 feet, records are showing that it's 200, 300 feet above current sea level. How soon is this going to happen? Don't know, never done this before. Is it gonna happen? It's hard to see how it's not gonna happen. But you can't say that it's definitely gonna happen because we've never had this before. Any questions about this? Kind of important to understand this dynamic. You know, some people say, well, we're already in a hot area. Well, we are relatively in a hot place based on the cycles, but we've never had this push before. And they've always stayed even with each other. So where's temperature gonna go? Next slide, please. So what about the oceans? Most of the carbon dioxide gets absorbed by the oceans. Of course, the oceans cover most of the globe. It falls into the ocean. It falls somewhat by gravity, but also any kind of storm, wave action helps mix the CO2 with ocean water. When you mix carbon dioxide with seawater, it forms carbonic acid. Not important to know that, but it's important to know carbonic acid dissipates quickly, but it makes the ocean more acidic. Okay, acidic ocean, acidification of the oceans is occurring 25 times faster than in the past million years. Why do we care? Well, seafloor trawling and dredging is another one, releases vast amounts of CO2 and methane. If you've ever anchored in an area where nobody's anchored for a long time, you might notice some bubbles coming up. Is that fish talking to you? No, it's methane and oxygen and carbon dioxide being released. Okay, so the seafloor is full of it. It's because it's been packed down. It's not necessarily fossils, but it's decayed matter. It's methane being formed from decayed matter on the bottom. And once you disturb it, the gas comes up. So acidic oceans do not support the formation of calcium carbonate. Why do we care? Because calcium carbonate is the basic building block of corals, shellfish, and vertebrae. And this includes lobsters, scallops, clams, crabs. They can't live in acidic water. So another factor with concentration, and this is Woodhull saying that the production of phytoplankton, which is the basic building block of the food chain in the oceans, it is in decline in the lower oceans. Next slide. So what is warming causing? Oceans absorb most of the increase in temperature as well. Warm air, water gets warmer. We all know that from what we see here. Warming oceans hold less oxygen, creating more and larger dead zones. Dead zones are something that were pretty much unheard of years ago. Every once in a while you hear, particularly in the fishing community, there are areas where there's just nothing. You know, there's no kelp at the bottom, there's no fish in it. Fish tend to avoid the area, or you see dead fish floating on the surface. These dead zones are largely areas, it's not necessarily somebody dumped a lot of chemicals and pollutants. In most cases, it's lack of oxygen. All the life is getting starved. So, I took this chart from Climate Change Institute, which shows showing what's happening to the temperature, mean temperature in the ocean. So what's happened in this short period is we have more than 1 degree Celsius increase in ocean temperature.
Over what period? I can't read the years.
This is 19, sorry, I think it's 85. It's really recent.
Yeah. Okay.
Very recent, very recent. So warmer water is going to screw up, warmer air is going to screw up circulation, warmer water is going to screw up circulation. A lot of talk about the Gulf Stream slowing down, meandering more. If you've ever sailed Bermuda race, you know, you look for those meanders in the Gulf Stream. They used to be hard to find. They used to be, you know, some years you have them, some years that don't. Now they're out there all the time. The Gulf Stream is just doing its thing. It's drifting along. I'm not saying it's due to climate change, but if you look at the last 2 big storms that came up on this coast, they didn't really follow the Gulf Stream. Essentially, they crossed right over the Gulf Stream. They came in from the southeast and right into the Gulf of Maine. Historically, the Gulf Stream would have kept those ongoing. If a storm was that far out, there's no way it would have come back to the northwest. So people talk about the Arctic and worried that once we have shipping and commerce going back and forth across the North Pole, is that going to mean a lot of sea level rise? And to that I say, think about your cocktail. When your ice melts, your drink doesn't overflow. So melting ice doesn't raise sea level, which is why the Arctic by itself is not raising sea level as it melts. It is going to change. The pH is changing slightly, which will raise it slightly, but what we have to worry about is when the ice, huge amounts of ice, miles thick in Antarctica, Greenland, other places where you have glaciers, when they melt, that goes directly to sea level rise. And that's where the big rise is going to come from. Next one. So what's happening in the air? Well, the polar vortex and the jet stream, which traditionally follows sort of a nice sine wave going right around the Earth, they're all screwed up. And starting with the polar vortex, it's going up and down. I mean, there are some days where phenomenally high temperatures at the North Pole. We get that weekend last year when it was, depending on when you were from home, it broke. It got mighty cold around here. That was a polar vortex coming way south. So the Gulf Stream follows it, and the Gulf Stream, instead of going like this around the Earth, it's going like this. Sometimes it backs up now, and sometimes it squeezes down so much that a storm gets stuck. You can have a storm that instead of moving along at 15 miles an hour or something, it gets stuck someplace, and that's how you end up getting rain that won't stop. I mean, who ever heard of Maine getting 4 inches of rain? You know, it's nuts. 4 inches is mild, but so a lot of places are getting unimaginable amounts of rain. Places that used to be pretty temperate areas, some of them are becoming deserts, others are becoming too much rain, and a lot of this is due to the fact that jet stream and polar vortex are slowing down, meandering more. So we're changing weather patterns. Permafrost is a huge problem for methane. Permafrost, which the biggest area of permafrost is northern Russia, but any place that you have a huge thickness of whether fossil or not even fossil, where you have organic matter that is built up over years and it contains methane. As it melts, the methane will come out and get released. So methane clathrate is basically when methane is trapped in ice. So if you look at a glacier or any of the poles, you have a lot of life. You have bugs, you have animals, you have plants, and as they die and they get snow on top, and more animals, they get snow on top. So what happens to all those trapped organic materials? They produce methane, but the methane is trapped, and that's the clathrate. So as that stuff melts, it's not just producing water, it's releasing lots of methane. Well, I figure it's releasing methane at the fastest rate in millions of years. Our climate is changing too rapidly for many species to adapt or evolve. It's leading to extinction of species, loss of biodiversity, more invasive species, loss of traditional food sources, loss of habitat, and climate migration. Now, when people talk about climate change, most people, the first thing they think of is the weather going to be different? Do I have to worry about my waterfront property? These are the issues that are much bigger issues. Where's the food going to come from? You know, I've talked to some people who have bought land high in the mountains thinking, that's where I'm going. Fine, where are you going to get your food? It's not, we're all in this together. Excellent. So what should we all be doing? You all remember reduce, reuse, recycle? Hasn't changed, except pretty hard to recycle in Maine. So you can recycle paper, corrugated paperboard, some glass. Quick story, but when Katie and I lived in Swellesley, Massachusetts, we first moved there and we asked somebody, so what day is trash pickup? And they said, no trash pickup in Wilson. You have to go to the dump. When do you have to go to the dump? All these rich people, these multi-million-dollar houses, they go to the dump. Yeah, they go to the dump. So we go to the dump. And first you come to the glass area. And there it asks you for your clear glass and your brown glass and your green glass, which you've pre-separated at home. And then you go to the plastic area. And it has 1, 2, 3, 4, 5, 6, 7. And you have to separate all your plastics and put them in there. And then comes the paper, and once you're corrugated, once you're fully cartoned, once you're mailed. And then after that, they had areas for paints, and the paints were broken down into oil-based and acrylics, and then they had, you name it, everything. And they had a huge swap shop, and they had a huge book library for exchanging books and things. And then they had an area at the end where you could take all the compost you wanted. I mean, truckloads of compost, because they were producing so much. That year, Wellesley dump returned $800,000 to the town of Wellesley. $800,000 profit from recycling. So what you have to know about recycling is there's high value only if it's well segregated. Number one, plastics, for instance, your soda bottles, etc. That you can get, I don't know what the number is now, but it's probably $300 a ton if it's clean, not mixed. Once you mix it with other things, other plastics, you're lucky to get rid of it. You probably have to pay to have it taken away. Okay, and that's true of most recycled materials. So recycling is really only going to work if it comes down to the consumer level. And here we come back to human nature. I can't tell you how many people say, there's no way I'm going to do that. I'm not going to separate everything like that. How did it work in Wellesley? Because Wellesley has 3 colleges, and the college students went door to door through the town and basically talked to everybody in town, so we have to do this. And they sold people on doing it. So it works there. So whatever, recycling is another topic. Understanding your carbon footprint. And by carbon footprint, it's not just how much propane, how much oil are you using. Your carbon footprint is everything from how often do you use your car? Do you economize and make the fewest trips possible? Obviously, what kind of car do you have? What are your driving habits? Are you a jackrabbit start person? Basically looking at everything you do that consumes energy. And I look at this very much, if you think of the fundamental idea of continuous improvement, then everything you do all day long affects your energy consumption. Everything from driving to brushing your teeth and everything between. So changing from a fossil fuel economy will be expensive, as we all know. But if we can get there, solar, geothermal, hydro, wind, hydrogen, and nuclear power with smart grids will have lower total costs than what we're doing now. That is absolutely true, that the world will be better off, we will be cleaner. I don't know if you know, but the vast majority of all cardiopulmonary ailments are caused by fossil fuel. Okay, fossil fuel is to blame for more of cardiopulmonary problems than anything else.
You mean the emissions?
Emissions, thank you. The emissions of, thank you. So the cleaner world, if we can get there. And each of these different energy sources has a part to play. Nuclear has to be part of it. Smarter grids has to be part of this. Just as with small modular reactors, it needs its own grid. So it's going to be very expensive to build all that. But the federal government, the state governments have to buy into this, which they're not at this point. Not adequate. Renewable energy will be clean, will be more sustainable jobs. So people, a lot of unions, for instance, that were opposing green energy, they've got to understand that they just have to retrain. There will be plenty of jobs in the sector, and they're sustainable jobs. They're not dirty jobs. So key point for everybody here is vote. What can I do? Some people say, well, you can change your car, you can do a lot of things, but probably the biggest single thing you can do is to vote. Pay attention to the candidates, talk to the candidates, but vote. Last slide. So Do your legislatures fully comprehend climate change? The answer is probably no. Make it your business to get them on board, to learn. Can individuals make a difference? Yes. But you've got to take responsibility for everything you control, everything you can influence. I emphasize influence, not just what you can control. Because influence is also peer pressure. Talking to other people about this. If you have friends who don't believe any of this, engage, talk to them. Get the climate committee to talk to them. Do we care what the future holds? A lot of people jokingly say I'm doing this for my grandchildren or great-grandchildren. It's happening a lot faster than I thought it could happen when I started giving these talks. It scares me because when I started giving these talks, I was talking about hundreds of years in the future. And that's, the whole thing is accelerating. It's squeezing down much tighter. Can drawdown be achieved in our time? Drawdown is basically where we can reduce and sequester enough greenhouse gas so that we are reducing it faster than we are producing it. Don't know if we can get there, but drawdown, for what it's worth, is also a project, and it's a great website. It's a great book, drawdown.org. It's probably the largest collection of solutions, both solutions for less emission and also for sequestering greenhouse gases. So that's my talk. It's not supposed to leave people scared to death, but I'm scared to death. It's supposed to leave you energized to do something about this. And if there are people that don't believe any of this, I would love to go through any part of this or any extension of this, or talk about the chemistry, talk about any aspect of it.
Very good. Thanks, Carl.